Hello, it's Keith here, and this is lesson 4 of the so-called simple series of my MIPS assembly programming tutorials. Today we're looking at the PlayStation. We're going to move a simple bitmap around the screen. Now here we've got my example emulator here, and we've got the ChibiAkumas mascot. That's the mascot of my YouTube channel, my website. And if I use the simulated joypad, the cursor keys in this case, the ChibiAkumas is moving around the screen. Now you might wonder why it's leaving this strange purple trail behind it. Well, that is to demonstrate something that I found quite interesting with regards to the drawing functions that I'm using here. Now, to get the character onto the screen, I'm transferring a bitmap from the main processor to the graphics hardware. I'm defining the area and sending the byte data. To remove it, I'm using the clear function. Now, it seems that clear function is limited to 16 pixel alignments for whatever reason. I'm not quite sure why. With the documentation that I saw on the hardware didn't really mention this, but I guess maybe it's relating to the bit planes somehow. So some of these systems work within bit planes, which is where the memory is organized in a different way, and so maybe it's using 2 bytes and it's writing the bit planes consecutively, or maybe it's something else. But anyway, basically I've had to work around that when it comes to removing the character from the screen. On most systems I would use XOR, but because I can't directly access the VRAM, that's not been possible in this case, and that clear area function doesn't quite work as I'd expected. So as I say, I've highlighted it purple just so you can see what area is actually being cleared by the removal function. If I was going to make this test do the same as the other systems, I would have filled the area black, but that wouldn't have represented exactly what was going on. Now, this isn't really intended as a thing for you to use in your own games. It's just really an initial example, shall we say. I've created this example on all of the systems in my tutorials. These tutorials originally started on 8-bit systems where moving a bitmap around the screen, you know, if you were talking the kind of Pong area of gaming, then that actually was enough to start writing a little game. It's not really enough on a PlayStation, but you know, for completeness and to be able to say that you know, we've done the basics, I thought it was still worth doing. So that's what we've done today. This is the PSX joystick example we're looking at today. And the first thing we're doing here is we are initializing our screen. So we're loading the address of the IO base here into A0 here, the upper immediate there. And then what we're doing here is we're basically setting up our screen. So here we are defining our screen. We're defining 320 by 240 16-bit per pixel screen here. And then what we're doing here is we're defining the drawing area. And basically we're just defining the entire screen as the valid drawing area here. And then we're loading a valid stack pointer. Now, when it comes to our test data, what we're going to do is we're going to basically read in from the joypad, and we're going to move our player object around the screen. And so we're defining two 32-bit values, player X and player Y, for the position of the player. And we're defining some joystick data area. We're going to use the BIOS to read in from the joystick, and that needs some memory to work with. Okay. Now what we're doing first here is we're running a clear screen routine here. Let's just take a quick look at that. We have covered it before in the bitmap series, but maybe you haven't seen that. Basically, what we're going to do is we're going to use the GPU's ports, and we're going to define the command we want to use, and the function is going to be clear screen. Now the 02 here is the command we want to use, and the remaining bytes are the actual color we want to clear. So 2 is the clear screen function, and then what we're going to do is basically define the area from 0 to the end of the screen. 320 by 240 basically is the area we're defining there. That's what those hexadecimal bytes are defining. So transferring that is effectively performing the clear area, and that is clearing the entire screen in that case. So that's what we're doing there. Now once we've cleared our screen, the next thing we're going to do is we're going to initialize the joypad. Now we're going to use a BIOS function here. We're using function B, which has a memory address of B0, and we first need to run the initpad function, which has function 12 in hexadecimal there. This takes 4 parameters, a buffer and a size for port 1, and a buffer and a size for port 2. We only need port 1 here, but basically that's what we're doing here. We're loading T0 with B0, which is the address of the BIOS function call. T1 we're loading with 12, which is the initpad function, and then we're loading our 4 parameters into A0 to A3 here, and we're jumping to T0 to execute that call, and that is initializing the joypad. That's not actually starting the read in, so we need to use function 13 to do that. We're loading T1 with 13 there and running that function as well. At that point, basically joy data will now contain the directions and fire buttons for our joypad, and all we need to do is read in that when we actually want to do things. Okay. So what we're doing here is we're initializing the start position of our player at point 0, 0, and we're running the draw player routine, which we'll take a look at in a moment. Now the PlayStation's very fast, and so we've got a simple accrued delay here just to slow it down enough for this to actually be usable. And what we're then doing is we're reading in a byte from the joystick data. Now we're reading from offset 2, which is the directions, and we're loading that into A3. And so what we're basically going to do is we're going to see if any of those directions are pressed compared to 255. If the value being read in is 255, nothing's being pressed, and so we don't need to do anything yet. But once that is pressed, basically our player has moved, or has pressed a direction at least. So what we're doing first here is we're running the remove player routine here, which is basically going to clear the player off the screen. We're then going to test each of the directions. Here we're testing right. Now that is that button there, and if that bit is 1, then that direction isn't pressed, so we're skipping down to here. If that direction is pressed though, what we want to do next is check the player's current position and see if a move to the right is actually possible. Now our screen's 320 pixels wide and our character is 48 pixels wide, so we're checking if our character is flush against the right hand side of the screen, and if they are, we're going to skip over because we can't move in that direction, but otherwise we're basically adding 1 to the X position of our player. So that's how we're processing the right direction. We're basically doing the same for the left direction here, and we're going to see if the player is at the far left of the screen. Our coordinates of our player is basically the top corner of the sprite. So if the player is at position 0, that's valid, but they can't obviously go below 0. So again, we're doing the same for left here. We're then doing the same for down and up here. We're just using different registers. A0 was our X position. A1 is our Y position here, and we're then storing the new value for the X and Y position back into the variables here. We're then using the draw player routine to show the new position of the player if the player has indeed moved. Maybe they haven't if they were already at the far extent of the screen. And we're then repeating, and that's how we are actually processing the directions and moving the player. So let's take a look at that draw player routine. Okay, it's basically the same as the one we used in the draw bitmap example. We've just been tweaked a little bit for calculating the coordinates. So what we're doing here is loading in the X and Y position here. Our width and our height of our bitmap are 48 by 48, and our bitmap here is defined here. Now this was created with my Sprite editor. The bitmap has been created in the correct format, and basically the bits are in this format here. It's a little endian bitmap file. So that's what we need. As I say, if you go to my website, you can download my Sprite editor. It's included in the downloads, and it's a simple bitmap editor you can use to create a valid file. Okay, so what we're going to do is we're going to transfer the bitmap data from our processor, our MIPS processor, to the GPU. So we're going to need to use a sequence of commands here. We're using command A0 here. That is send image to frame buffer. That's transferring our bitmap image from the CPU to the graphics memory. We're then defining the X and the Y position here. Now I've basically got a multiplication here. I'm shifting the Y position to the top 16 bits of the 32-bit value there and adding the X position here. So we're taking our X and Y position here and we're shifting them into the correct position here and sending that to the GPU. We're then doing the same with the height and the width. Now this could be hard coded, but just to make it more convenient for you, if you were reprogramming this and maybe you're using an 8x8 sprite for your Pong game or something, well, now you can just change A2 and A3 here and get the data transferred a bit more conveniently there. So that's what we're doing there. And then what we're doing next is we're going to transfer all of the bitmap data from our source bitmap to our hardware. So we're reading in the bytes here and we're sending them, but we need to calculate the correct number of bytes, and so that's what we're doing here. We're taking our width here and we're effectively dividing it by 2 because we're using 2 bytes per pixel, but we're going to transfer 4 bytes at a time here. So we're converting to a number of 32-bit words here and we're multiplying that by the height, and we're subtracting 1 here for the way that our loop is going to work here. But basically that's what we're doing there, and then we're just transferring all of the data. And then we're returning here. So that is showing our bitmap to the screen. Now on other systems I would use an XOR function to remove it from the screen, but I don't actually know if it's possible to do that. So what I'm doing instead is I'm using the same clear function that I used before. Now this was used for the clear screen, but this time we're not going to use the entire size of the screen, and we're going to have to calculate the position. Now as I say, this seems to be limited to 16 multiples of 16 pixels, so we're going to have to compensate for that. So we're adding 16 to the width to compensate there. A2 is the width there, A3 is the height. And basically we are defining here our fill command 02, and then we're defining a color that's basically dark purple. That 0F, 000F is dark purple there. And then we're transferring our command here. We're then calculating our X and Y position, basically in the same way as we did when we sent the bitmap data. We are calculating our width and our height here, again, in the same way as before. But we don't transfer any bitmap data. This is a flood fill command. So once we've sent the width and the height, the fill will actually occur. There's no kind of data transfer. Now, we could have sent a bunch of 0 bytes here instead. That would have got around the limitation of the 16 by 16 area. But that wouldn't have been very efficient. Now, truth be told, of course, if you wanted to make a legitimate game on the PlayStation, you would want to be using probably the 3D hardware, even if it was just to create a transparent object on the screen and then move that square around with your sprite on it. That would be the more common way of doing things, but that's outside of the scope of my tutorials. These tutorials were really originally intended to be 8-bit, so we're in these 32-bit processors and things, so we've gone kind of outside of the scope, and I'm not going to be covering 3D content, so you'll need to see someone else's tutorials if that's what you're interested in. If you like this content, please like and subscribe. We'll be coming back and doing more later on. You can also consider buying one of my books. I have two. This is the first one. It covers Z80, 6502, 68000, 8086 and ARM. And my second one covers 65816, 6809, PDP-11 and RISC-V. So maybe one of those will interest you. I don't have a book on MIPS at the time of doing this video, but I do plan to do one someday. Anyway, I hope you've enjoyed what you've seen today. Thanks for watching and goodbye.